Hello and welcome to day 4, where today we're going to put different transformations together, and we call this compositions. And so the first question says translate the point using the rule. So another way I could write this rule is big T 2 comma negative 5. So basically I'm adding 2 to the x coordinates and I'm subtracting 5 from the y coordinates. So I use a little prime symbol to indicate that's moved. So 2 minus 1 is 1, negative 5 plus 4 is negative 1, and then n prime would be at 2 comma 4. All right, and then the second question asks, what are the different transformations you see in this picture? Well, this is a great image of a translation and also a rotation. Like you can see that these dinosaurs are rotating. The yellow one, the red one is a rotation of the yellow one and vice versa. And over here, this is a great illustration of a reflection across the y-axis as well as a reflection across the x-axis. So those are some things you should have said. All right, next, there is a link. If you want to see one of the most famous artists is M.C. Escher, and he worked a lot with composition functions to make really cool graphic artwork. So if you want to see some of his artwork, there's a link in Canvas. You can pause this video and go over there and check that out. Otherwise, let's continue on. So this is an example. These ants are an example of something that he would draw. This picture right here. All right, so a composition of transformation consists of 2 transformations in which the second transformation is performed on the image of the first. So you do the second and then the first, okay? So when you're seeing a composition function, you'll see this little circle in the middle right here, and that indicates that you're going to do this part first and this part second. So you basically work from right to left, which is kind of odd whenever you see that little degree symbol in the middle of some things, okay? So let's go ahead and start. How would we do this? So these little R's should indicate R says we're going to be reflecting, okay? So let's start by graphing the point 2, 5, which is here, okay? Then the first reflection, we're going to reflect across y equals 3. So again, we're going to go to the y-axis. Here's where y equals 3. I'm going to draw my line. And I'm going to reflect this across, which is right here. Then the second reflection says I'm going to go where x equals 4. Well, this is where x equals 4. So my second reflection is here. And then I want the coordinates of this point, which are at 6, 1. So my final solution would be 6, 1. So what I did was I did a double reflection composition function. All right, another example. We're going to start with hat. Once again, we're going to reflect twice. What I like to do is write the rules. So if I'm going to reflect first across the y-axis, I know the rule is negative x comma y. And then I'm going to reflect on the y equals x line, and I know that rule is y comma x. The coordinates flip-flop. So first I'm going to change the x, and then I'm going to flip-flop the coordinates completely. So my original drawing is at 1, negative 2, 4, negative 3, and 0, 5. Okay, so it looks like this. Okay, then my second here, I'm going to change the x to negative, so it'll be negative 1, negative 2, negative 4, negative 3, and then 0, 5 stays where it is. So I'm essentially reflecting across the y-axis here. So it should look like this now. Okay? And then the third rule says I'm going to flip-flop. So I'm going to use the previous one. It's going to be negative 2, negative 1, negative 3, negative 4, and then 5, 0. Right? So now I can go -2, -1, -3, -4, and then 5, 0, 2. So essentially it looks like this because I'm reflecting across this line here. That's the y equals x line. Awesome. All right, let's look at example number 3. It says, which of the following is equivalent to this composition function? So first, I'm going to translate 2 comma -4, and then I'm going to translate 2 more and +4. Okay, so I want to know which answer choice is equivalent. So I'm going to go ahead and start at 0, 0 because it's a translation. And the first one I'm going to add 2 to the x and subtract 4 to the y. So now I'm at 2 -4. Then I'm going to perform the second function, and that puts me at 4, 0. Okay? So the correct answer choice is here, number 3. If I wanted to see that, again, I just came up with an example. You could use any example. I'm going to go over 2 and down 4. Okay? So that's my first. This is t. This would be t prime. And then I'm going to go over 2 more and up 4. This is t double prime. And you'll end up see that I ended up at 4 over, and I didn't go up or down at all. I just went really across 4. All right. Try the next one on your own. Oh, wait, no, I wanted to show you a couple more examples. Sorry. So this is a glide reflection. So a glide reflection is essentially what it says. A glide would be a translation, and then a reflection would just be a reflection. And what's cool about a glide reflection is that it's commutative. And so what that means is it doesn't matter which one you do first. You'll still end up in the same spot. So let's try this out and see what happens. So for this one, we're going to first translate and then reflect. And over here, we're going to reflect and then translate. So I'm going to start with A, which is at -5, 5. B is at -3, 2. And C is at 1, 5. C. Now I'm going to translate it. So this is step 1. I'm going to go ahead and translate it down 7. That's step 2. So I'm going to take each of these points, 1, 2, 3, 4, 5, 6, 7. Like this. That's my image after a translation. Now I'm reflecting across the y equals 3 line, right? So that looks where on the x-axis where x is 3, excuse me, it's right here. And so I'm reflecting across. This is 2 away, so I have to go 2 away here. This is 5, 6, 7, 8 away, so I have to go 8 away. So over here, and this is 3, 6 away. So this is my final image right here. That's where I end up. So let's see if that same thing happens if I reflect and then translate. So I'm going to start over here at -5, 5. And then I'm going to go to -3, 2. And 1, 5. So here's my original image. Second image now, I'm going to reflect across the y equals 3 line, which is here. So this is 2 away. This is still 8 away. And this is 6 away, which is here. Okay, and now I'm going to translate 7 units down. And what you'll notice, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is 5, 6, 7. Check it out. This, my final image here and my final image here are in the exact same position. So for a glide rotation, it doesn't matter the order. You'll still end up at the same spot. It's called the commutative property. So go ahead and try this one. Pause the video, try this one. Come back and see if you did it right. Remember, you're learning when you actually pause the video, work the problem, and then check. Just copying doesn't teach you anything. And I've shaded in the final image, which is in green, so I translated and reflected. Now, if you did it the opposite direction, you would have ended up at the same spot. Okay, let's, it's called a glide. Glide meaning translation. Okay, this is your classwork for today. So your homework and everything is going to be to finish the packet. And then finish the packet, and then you have these IXLs to do as well. At the end of class, you can come back and check to make sure that you did it correctly, or you can wait till tomorrow when we go over it in class. Here are the answers for 1 through 7. If you notice, a couple things I wanted to point out is that notice every time I see, like if they say x-axis, reflection across the x-axis, I write the rule right next to it. Again, if you don't know the rules, they're on that poster on the side, on the windows, it'll say transformation rules, and these are the ones under reflection, rotation, they're all there. Then for number 5, another thing to notice is that the point 0, 0 is never going to change because it's the origin, and whether it's reflected, rotated, or whatever, it's going to stay right where it is. You can kind of see how if when the rule is x comma negative y, that doesn't mean that the y always goes negative. It means that you change the sign of the y. So if you look at number 1, the y was positive, so it went negative. And if you look at number 2, the y was positive, it went negative. And if you look at number 3, the y was negative, and it went positive. Translation, if I give you this, the 2 points, you need to figure out what happened to the 2 points to get to the new point. So I noticed that 4 minus 1 is 3 and negative 4 plus 4 is 0. Okay, and then down here, your answer might vary for letter D, but what I'm more concerned about are your answers for A, B, and C. Did they match up? And notice I didn't use the drawing. I just went ahead and followed the rules and looked at the coordinates, which is completely acceptable. For number 8, again, I didn't draw it, I just used the rules. Now remember that in the composition function, you do the second thing first. And I wrote the rule right here, y comma x. These are my points. And then I noticed it's the 90 degree. Remember, it's counterclockwise unless otherwise stated. And so these were my new points. And then for number 9, again, you start with number 2, which is a translation of 3, negative 4. So you add 3 to your x's, and you subtract 4 from your y's. And then the second was a rotation across the x-axis, and this is the rule. The x stays the same, the y changes. And here are my new coordinates based off of the red. And so that's where your final image should end. Again, please make sure you're finishing the packet for homework, and you're working on L2 for 5 and 8. Those are due Friday. Your test will probably be next week, Tuesday or Wednesday. I haven't decided yet. All right, guys.